Welcome back. We're going to start in on to Chapter 12, Shielded Metal Arc Welding Electrodes. This is where we're going to break down some of the electrode designations, help make sense of them, and explain what all the numbers and letters mean at the end of the electrode and so forth. Okay? So let's start out. We have our objectives. Introduction to Shielded Metal Arc Welding. Acronym of SMAW, Shielded Metal Arc Welding, also known as stick electrode welding. Again, we're trying to use the proper terminology. There are still a lot of places in the country that most people call it stick electrode welding or stick welding. As long as you know that the correct abbreviation or the correct terminology should be shielded metal arc welding, that's what matters to me. You hear it in the shops all over the place. So just grab some sticks and go weld that up. And that's fine. It's one of the most widely used welding processes of fabrication, maintenance, and repair of metals. Again, we talked yesterday about the percentage of usage of shielded metal arc welding, mainly in fabrication and maintenance and repair. Good examples. We'll see most of these in the welding shop. We'll go through a lot of this. However, let's hit a few points here. So you notice how this weld profile is very tall and crowned over. Looks like it didn't get that great of fusion into the base metal and so forth. On this side, you can see that it's exact opposite. It's really wide, very flat. So that's really high welding current. You know, we've got some like V-shaped notches within our welding material. That also means we're going too fast. Of course, we have to with too high heat. In this case, it's a nice rounded profile. We went probably about the correct speed. However, we just didn't have enough current to be able to fuse into the base metal. Okay. Welding speed's too fast. Again, here on the right hand side you can see we've got our sharp elongated notches. Now certain materials, we're going to kind of look for that as well. So sodium cellulose rods is in 60-10, 70-10, 80-10, 70 plus, so forth. You're going to want to see a little bit of ripple, but that's some different manipulation of the electrode for different reasons as well. You'll see this, it's very common in API 1104. We'll discuss that on a one-to-one basis as we're welding in the shop. Okay. Too slow. This one's about right. Okay. So you can see this one's real wide. Now this one can also be associated with a weed bead. You know, if you're covering a couple distances, you may see a couple rod distances. You may see a little wider profile. It's got a nice gradual roundedness to it. The weld beads look pretty good. You know, there's a little bit of spatter, so forth. We'll discuss that in the shop itself. But on this one, this is a nice single bead, just a stringer bead dragging it along instead of a weed bead. Okay. All right, so we're going to start out of the book, page 310, chapter 12, right-hand column underneath, Introduction to Covered Electrodes. The type of covering influences the degree of penetration of the arc and the center depth. Now that's a bulleted point. Definitely. So it affects the extent of the recrystallization and annealing of previously deposited layers as well. Sorry, let me back up here. I read off the PowerPoint. Now we're going back to the book. Page 310, under that same paragraph. Let's read that paragraph, and then we'll come back to the PowerPoint. The type of covering influences the degree of penetration of the arc and the crater depth. The proper electrode selection therefore makes it possible to obtain sound welds in close-fitting joints and to avoid burning through properly fitted joints. Again, everything is relative to what we need. There are times when we're going to want to open up the keyhole and make a burned through weld joint, okay? All right, let's continue reading. Since the covering influences the extent of penetration, it affects the extent of recrystallization and annealing of previously deposited layers. This characteristic improves the internal or the radiographic quality of the weld. The low electrical conductivity of the covering permits the use of electrodes in narrow grooves. The covering also reduces weld spatter. So it helps stabilize the arc as well. Okay, so let's go back. I want to catch something real quick. So radiographic. Okay, radiographic is one means of non-destructive testing. Okay, so just to clarify, it improves the internal quality of the weld. That's the main portion. The radiographic piece, that's how we're going to come back to see the internal quality of the weld, to make sure that there are no discontinuities or within a code specification. All right? Just to help clarify there a few things. Low electrical conductivity of cover permits use of electrodes in narrow grooves. So again, if we've got a groove only so wide, and say it's only 1/4 inch wide, and our welding rod is a 1/4 inch wide at the top, but it's a 1/2 inch deep electrode, it's going to be hard for us to get down to the base of the weld groove. Okay? Take a break here real quick. Let me help explain it. Say this is per size, or per scale, okay? Say our welding electrode only gets here, okay? It's hard for the filler metal to get all the way down and to break this edge down and weld it properly. And that's part of what they're discussing there. Okay, here's our rim steel. The outside is our coating, okay? So what we need to do in that case is we probably need to come in and either open our groove up if allowable. So our root opening needs to expand. So then our welding electrode would actually fit within that weld groove and get down into the root opening to where it would create a solid weld. Okay? And that's what we're discussing about the electrode covering can sometimes be too large to fit into the groove. All right. Let's move on to the next piece. Protective gaseous atmosphere and slag covering. Okay, so we're under the functions of electrode. In the book, we're page 311, chapter 12, underneath functions of electrode coverings. Let's read from the book. Now this paragraph has several bulleted points in it that could come out of questions, could come out of it, so forth. The covering materials on the electrode provide an automatic cleansing and deoxidizing action in the molten weld pool. By supplying a protective gaseous atmosphere and blanket of molten slag for the weld metal, the covering excludes harmful oxygen and nitrogen, hydrogen as well. The extent of gaseous and slag protection depends on the type of covering. In addition to protection, slag performs the following functions. And I would understand what these bulleted items do. I would kind of keep those in mind going through this, okay? Acts as a scavenger in removing oxide and impurities, slows down the freezing rate of molten metal, slows down the cooling rate of solidified weld puddle, and it controls the shape and appearance of the deposit. It affects operating characteristics, electrode positive, alternating current, etc. Depends on what type of coating. Sometimes will depend on the operating characteristics as well. So if we're going for a say we only have a alternating current machine, okay? We probably want to be looking at a cellulose potassium rod, so a 6011, or a titania sodium rod, which is 6012, versus a 6010, which is the cellulose sodium. It requires an electrode positive, a DC rod only, or a DC current only, okay? Let's go down to the 70 series. Let's look at a couple others that could quite possibly be there. Now 7024 is a good one. It can be used in all three. It's an iron powder titania. Alright. We'll break this down. We'll break down those numbers so that you understand what they mean. Keep going as we're there. This gives us a good example. Up here on the top shows kind of what I was showing earlier about being able to get within the groove depth to the full extent that we need to. Alright? Okay, let's continue reading, page 311. The alteration or restoration of base metal. Uh-oh, something happened with my... PowerPoint here. All right. Okay, reading from the book, page 311, left-hand column underneath alteration or restoration of base metal. To a large extent, the covering controls the composition of the weld metal, either by maintaining the original composition of the core wire of the electrode or through the introduction of additional elements. In this way, alloying elements are added to the weld metal or lost elements are restored. For example, molybdenum and vanadium may be added to the covering because these alloys produce better physical properties in the weld metal than those possessed by the core wire. On the other hand, manganese is usually included in the covering to maintain the same manganese content in the weld metal that was present in the core wire. The coating may also be balanced to adjust the carbon and silicon content of the weld deposit. Bolded item coming up, keep reading. The addition of large amounts of iron powder to the coating of an electrode increases the speed of welding and improves the weld appearance. In the intense heat of the arc, the iron powder is converted to steel and contributes metal to the weld deposit. So we kind of talked about that in chapter 11 a little bit. I said we'd get into it a little further as we're going along. Let me finish this paragraph and then we'll talk about it. Low hydrogen electrodes greatly improve the welding of high carbon and alloy steels, high sulfur steels, and phosphorus bearing steels. Such steels tend to be porous and crack under the bead. The reduction of the hydrogen content in the weld eliminates these harmful characteristics. Okay, let's take a break and we'll go to the PowerPoint. Okay. The covering controls composition of the weld metal, maintaining the original composition of core wire, and then the introduction of additional elements. Remember we talked yesterday how a lot of alloying elements can be put in on the flux. That way it can be dispersed in an even pattern while it's in the weld pool. So it kind of helps with distribution, and it also gives us a good balance point, introducing oxidizers and so forth to act as a scavenger and removing the impurities and so forth. Okay? So here we talked about the addition of large amounts of iron powder to coating of an electrode. So 7018 is one of them. 7024 is also an iron powder. These topics we talked in chapter 11 will have a lot thicker flux coating than other welding rods, so that way the iron powder will be able to add material to it. So it puts a lot more metal down. The deposition rate is higher. Okay. I'm going to stop here. We'll pick back up here in a few minutes.